If you're coming from the last video, you know that in the last video, we introduced this starter Arduino project where we are going to simulate the design of a product, and in this case, it's going to be one of those solar-powered outdoor lights. So what we arrived at in the last video is kind of how the hardware is going to set up, and then what we need to consider for the code. So we have some solar cell, some microcontroller, some battery charger that we're not too concerned with, and then we decided for simplicity we're going to drive the LED with the microcontroller. We set some minimum resistance value such that we didn't exceed the output current limitations. Now coding wise, we have three cases to consider. So if it's dark, the LED is on. If it's light, the LED is off. And then dawn or dusk, we know that we need to dim that LED. And in the last video, we learned how we can dim an LED using the pulse width modulation concept, or PWM. And I think just for this starter project, let's keep that static. So now that we're all set to start writing the code, we're just going to build on our knowledge base. So we're very familiar with variables, but we can introduce this concept of global and local variables. So a global variable is a variable that can be seen by any function. So we can actually define variables outside of the main. So in C++, we'd have the main, but for the Arduino IDE, it's actually going to be called loop. So we can also kind of define this read-only variable simply by following this format here. So it's similar to declaring variable, except now we add this constant right here. So to distinguish from the main and loop for the Arduino, and those will run like functions. So void setup, that's simply just going to run once. Think of configuring things only one time. And then we have our loop, which is going to run forever. So if we dive into this void setup a little bit, what exactly are we setting up? Well, we can look at pin modes. So that's setting things as either inputs or outputs. We can establish serial communication. This doesn't mean anything to us right now because we haven't talked about it, but we'll see it in the code. We can set initial values that we might need to use, or anything that doesn't need to loop can go in this setup. Now moving on, we can look at the analog and digital pins of the Arduino. And I think this is quite self-explanatory. The analog pins do analog things, the digital pins do digital things. But nicely enough, the analog pins can also do some digital things if we need them to, if we ran out of digital pins. And by default, if we don't specify any pin mode, a pin defaults to being in this high impedance input state. And because we have a high impedance input, we also have a negligible impact on any kind of circuit that we are sampling to try to get some data off of. Ignore the little typo that I had to correct there. But also because we have some high impedance input, well, it's also very susceptible to noise. So if we leave that input floating, it can pick up noise and give these false positives or false negatives. And maybe you might consider using a pull-up resistor or a pull-down resistor depending on the application. Now if we don't define something as an input and we specifically define it as an output, it becomes low impedance. And now the output can provide current to some circuit. But again, for our Arduinos, we don't want to exceed that 20 milliamps for that output current. Now there's some interesting quirks to the Arduino or the Arduino IDE, and that comes with defining the pins. So for the analog pins, it's pretty straightforward. If we look up the datasheet for the Arduino Nano Every, you can see here on the left, we have some analog input pins, A0 to A7. Then for our digital pins, we have D2 to D12. But then if you notice, also for the analog pins, you have D14 to D21, which match up to A0 and A7. So for defining the analog pins, we'd simply use A and then whatever number it is, so something like A1. But for the digital pins, we don't use D1 or D2. We just use whatever that pin number is. So it would be something like 2, 3, 4, 5. And the reason of this is if you look at the microcontroller on the actual circuit board for the Arduino, that microcontroller actually uses this D value. And because you saw those extra D values for the analog pins, you could also refer to an analog pin by the digital pin value. Now the trouble with this comes because what if we need some other variable set as the number 3, but we don't want to use D3? And it's actually not as concerning as you think it might be. So also remember this little squiggly line in the datasheet. If you're just looking at the pins, that would represent our PWM pins. So we know that our PWM pins are D3, D5, D6, D9, and D10. We looked up what that PWM frequency was in the last video. And once we know what pin we're going to use, then we introduce that analog write line of code. And again, the nomenclature gets a little bit weird again because we're using analog write for a digital pin. but nevertheless, we can actually finally get into the code. So if you open up the Arduino IDE, the first thing that you're going to want to do is go into Tools, go into the board, and select whatever board you have. And then you're going to also need to know which serial port you're connected to. So here you can see that the Arduino Nano Every is connected to this port 6. Then these two buttons, these are what we are going to be concerned with. So this check mark here on the left, that will verify your code to make sure there's no errors. And this arrow right here, that will upload the code to the Arduino. Occasionally you might get an upload error that doesn't really make sense and you might have to just try to upload it again. Not everything is perfect. But to dive into the code, it's a pretty short code, not even 30 lines. In line 1 and 2, we just make some comments to describe what the code does. In line 4, 5, and 6, we are declaring some global variables. Notice here, we defined this constant variable for the LED PWM pin. And we said that that's equal to 3, so that's going to associate to D3. We next define that solar voltage as A0, so that's going to be the analog input pin, A0, a little bit easier to understand. Then we define something as initial PWM, set it equal to 0. And the reason that we do that is because if we go into the setup, so again, this is only going to run once. The first thing that we can do is define some pin mode. So the LED PWM pin, which is going to be pin D3. We're going to call that an output. Solar voltage, or A0, that's going to be an input. And then we have this serial begin 9600, and this is going to initialize communication at 9600 bits per second. And what this is going to allow, it's going to allow us to kind of have a terminal that we can interact with. Now the reason we had this variable in line 6 is because we're going to initially set the PWM of pin D3 equal to that value, which is 0. So that's going to turn off that LED upon starting up. Now once this setup is finished, what we're going to do is enter our loop. So we're going to define some solar value here, and that's going to be equal to the analog value that we read off of solar voltage, which is A0. And this value is a 10-bit value that ranges from 0 to 1023. So if there's no light, we're probably closer to 0, and if there's a lot of sunlight, we're probably closer to 1023. Now we're going to use this serial print line solar value, simply just to show what this value is that we read. And this is going to get printed to the serial monitor. So this is just taking the input of that voltage and then showing us what that value is in the terminal. Now next, we are going to have our conditions. So if there's a lot of sunlight, we know that we are closer to 1023. And if it's dark, we're closer to 0. So based off of the room I'm in, I had to set these a little bit different. So if the solar value that we record is greater or equal to 600, we're setting that PWM value to 0, so the LED goes off. If it's less than 300, then we set that PWM value to be fully on. Otherwise, if we're not at the extremes of our conditions, well, we're going to set that PWM value simply equal to 25, which is very close to 0, so it's going to be pretty dim. And then we delay 500 milliseconds, and then because we're in this void loop, this runs over and over and over again. So what we can do, we can just verify that this code is okay. We got no issues, and then we can upload this code. So with these serial commands, you might ask, where is the terminal? And there's two ways you can get there. You can hit Tools, Serial Monitor, or here on the right, you can hit Serial Monitor here. So you can see here that we're outputting some value. There's a little bit of light in the room from the lamp above. So that's where that's coming from. If you actually cover up the solar panel, you can see that that goes down. Not completely because I'm doing a pretty bad job at covering it up. If I turn on another light, you can see that it increases. Again, we're not in direct sunlight, so we're not really going to max that out by any means. So this is our first project where we implement writing code into some hardware, making it do some functions that we define. In the next video, we're going to kick things up a little bit, make a little bit harder of a project, but show more features that Arduino can do. If you learned anything new, please like, comment, share, subscribe. Thank you for watching, and we'll see you in the next video.